Hi everyone, Lab Survival Guide is back. Today we're diving into cell culture contamination. How to spot it, stop it, and stay ahead of it. Ever had cells that looked fine until they didn't? Today I will cover contamination from bacteria, fungi and yeast, mycoplasma, viruses, and mixed-up cell lines. Let's troubleshoot fast. Your first clue is the color of the medium. It contains phenol red. Under normal conditions it looks like this, but it turns yellow when acidic, and pink when basic. So the first question is, did the medium's color change? If not, and your cells look happy and healthy, then everything is fine. If it did, but you know your cells are old, and anyway the media is clear, it's probably just a pH shift, not contamination. If the medium changes color, turns turbid, and smells off, you're dealing with microbes contamination. No color change, but the cells show unusual morphology, behavior, and performance. That's likely mycoplasma or viral contamination. If the medium looks fine and the cells seem happy, but their shapes aren't consistent, that's a strong sign of cross-contamination. Your microscope is your first line of defense. Check your cultures daily. Don't wait for visible symptoms to show. Microbes change the medium's color. It turns turbid and may smell. And under the microscope, you'll spot tiny moving particles. When the medium turns yellow, it indicates bacteria. When it turns pink, it indicates fungi or yeast. Mycoplasma and viruses are invisible under the microscope, and they slip past standard filters, but they leave clues. Mycoplasma contamination shows slow growth, altered morphology, and disrupted gene expression, while viral contamination triggers cell death. Abnormal cell shapes, inclusion bodies, and syncytia. Cross-contamination, not much to say. It's pretty obvious. You see multiple cell types sharing the same plate. So far we've covered how to spot contamination by color, turbidity, smell, and cell behavior. Now let's talk about how to confirm what you're seeing. To detect microbes, visual clues are enough. To detect mycoplasma, use PCR, luciferase assays, DNA stains, or agar culturing, the gold standard, but slow. To detect viruses, common methods are electron microscope visualization, PCR, immunohistochemistry, and immunofluorescence. Confirm cross-contamination with karyotyping, STR profiling, or isoenzyme analysis. Now the tough call: would you treat your cells or trash them? As a general rule, don't risk it, just discard. Only treat if the cell line is rare, irreplaceable, or part of a critical experiment. If you really have to keep the cells, there's something you can do. You can use antibacterial and antifungal to control microbes. These are widely used reagents for mycoplasma removal. For viral removal, treat with antivirals and quarantine the lab. Finally, re-authenticate mixed cell lines. Use antimicrobials and antivirals with caution. If you are wondering, where did the contamination come from? Well, I made a flowchart. Don't worry, I'm not spending my whole life on this. Mine is too short. I tried making a flowchart to trace the contamination source, but honestly it could be anything. Media, operator, equipment, cell line. To find it, go step by step. Or better yet, prevent it altogether. Good lab practices mean wearing dedicated gear, changing gloves often, staying silent in the hood, and never dipping into shared reagent stock. Always aliquot what you need. Lab cleanliness starts with a workspace. Wipe down surfaces with ethanol, disinfect regularly, clean shared equipment, manage spills quickly, and dispose of waste without delay. Use only sterile, filtered, pre-tested materials, and keep your equipment clean, maintained, and under control. Stay efficient. Keep tools close, avoid crowding, and set clear boundaries between clean and dirty zones. That's it for today's Lab Survival Guide. Spot the clues early, act fast, and keep your cultures clean. Thanks for watching, and may your cells stay happy, healthy, and uncontaminated. Subscribe for more lab sanity.